Hello and welcome to this talk on artificial intelligence in the classroom. My name is Carsten Schulz and I'm from the Digital Technologies Institute. In this presentation we're covering the following topics. We're going to look at what AI or machine learning is. We look at a couple of practical scenarios. We compare it to conventional programming. We look at examples in the classroom, consider the moral implications of artificial intelligence, and the links to human thinking and learning. We'll also consider links to the Australian curriculum and other resources to find out more. So what is artificial intelligence? Artificial intelligence is what we consider the ability of machines to mimic human capabilities in a way that we would say that is smart, or it mimics the human behavior. AI application examples are self-driving cars, chess or Go players, security systems, and perhaps an AI system that you've already used, a personal assistant such as Siri, Alexa, and friends. So let's look at a couple of practical classroom scenarios to give you a feeling about AI, how that could be used in a classroom setting. So I would like to ask you to go to the following link, www.mycomputerbrain.net. www.mycomputerbrain.net. That will bring you to this screen. Click on the login button here at the bottom, which will take you to an account page where you can create a free teacher account. I'll give you a few minutes to do that, and then you can continue with this presentation. So here is the website, My Computer Brain, and you will see a number of experiments and courses which you can check out, but for the purpose of this presentation, we're going to do the AI Hour of Code, which is here. Just click on this image, and there you see 7 experiments, and in order to activate an experiment, just click on the image, which will take you there. So that's our first experiment. You see a human brain, and the analogy is intended because artificial intelligence is based on brain research, and from there mathematical models and then computer models were developed, and today we're going to look at a computer model. So click the human brain, click on any of the arrows here, and that will push the brain to the back. What are we going to see here? We're seeing the eye, and the eye looks at different letters in this scenario, and then we've got our network here, the AI here, the artificial neural network, and then the intent is that the AI tells us what the eye is seeing. So this little block, the black box, tells us what the eye is seeing, and then we want this color to match here so that this A will also light up black, or in this case when an E is being selected, the E will light up black. Our AI has not been trained yet. Okay, so it doesn't recognize this. So as part of the AI development, we need to train our AI, and we're doing this by clicking on this button, Start Learning. Okay, and what we're doing now is the same thing that teachers are doing in the classroom. You would be showing students the letters. Let's assume you're a primary school teacher, prep or year 1. You're showing the students a letter and you're saying that is an A, or that is a B, that is a C. And you're saying this, you're using all the input channels that the student brains have available. You may also have shapes of the letters, which means you're using the tactile sense of the students. Doing this again and again and again, that is the learning process. We're not programming the students, we are teaching them. And the same is true with artificial intelligence. You see it's very slow. You can speed this up by dragging the slider here, and we speed up the process. So we're showing these letters now repeatedly and very quickly to our artificial brain, and you can see these colors changing, be it black or green or red, and these are the changes that are happening now in our neural network. The same thing happens in our brains when we learn. That means our synapses, the connections between the neurons, get changed. In our case, green means a positive weight, red means a negative weight, and black denotes that it's about neutral. Now, both is possible. We cannot say that red is bad and green is good. Both are necessary for a learning outcome. And we wait. Down here, the dial tells us how far our learning process has advanced. And the number varies, usually in the order of 200, 250 cycles for this experiment, until the network is certain enough that it has properly recognized all these letters A to J. It's finished now. So what do we see when we drag the letter here? There's an A, that's a B, that's a C, D, E, and you see how the network recognizes these letters now. Okay, we have not programmed the computer, we've just taught it. Okay, now the cool thing about artificial neural networks, or AI in general, is that it is able to distinguish patterns and to see similarities. So when we now expose it to a letter that it has never seen, it will compare this to what it already knows and come up with a probability. So in our case, if we start changing, let's say, the letter E towards an F, okay, see the difference only is these 4 bits down here. If we now start removing a bit, you see it is less and less certain that it is an E, and at this point it's most certain that it's looking at an F. The gray shading here denotes the certainty. So the more black, the blacker, the more certain. So here it's very uncertain about anything it's looking at. That's definitely an E. Here most likely an E. Not sure what this thing is. Oh, most likely an F. Yeah, this is most definitely an F. And this is how artificial neural networks work. So let's look at the next experiment that we can do. We can apply this. So let's assume we've got a home automation scenario. We know this from our personal assistants that we can control lights. So how might this work in real life? So we've certain inputs, like voice inputs. We can say switch lights on, and then we want the lights to go on. Or we say lights on, lights go on. If we go fan off, the fan should go off. And so there's many combinations of words possible. We cannot program all possible combinations of words, but we can give our artificial neural network a large number of examples and ask it to learn from that. Again, this network is not yet trained. We do this by pressing the Start Learning button. So as before, in the previous scenario, the system is learning now. Just to have to wait a little bit. I might speed this up for this recording. Okay. And in order to interact with the system, now we can type in words. Switch lights on. Okay, the lights should go on. Very good. If we want the fan and the lights on, we might say fan lights on, and that turns both the lights on and the fan on. If we say it's too hot, it is not entirely sure what we mean, because hot is not a word that it knows. But if we say it's warm, it would turn the fan on. So this is a way how we can come up with all sorts of combinations of words, but if the system doesn't know the word, of course, it doesn't help very much. So we might use a thesaurus here in order to help us to find words that are similar. Okay. We can use AI to help us with anti-bullying. The scenario in this example here is that we teach the AI about kind things and mean things, so that when we write a post on social media, the AI can warn us that something might be considered as a mean thing before we send that post. Okay, so let's make an example. I've got a few here. Okay, so a kind thing to say could be, I like you. Okay, so you see how we build the AI as we go. A mean thing might be, you smell. That's definitely a mean thing. Another kind thing could be, your hair looks nice. Okay, and observe how the AI is being built at runtime. I hate you is definitely mean. I think you are great. See, that's dumb. It's mean. You have a great smile. It's a nice thing to say. Your hair looks terrible. It's mean. You're so clever. What an idiot is mean. And finally, I love your outfit. Oops, outfit. And the last mean thing is slime ball. Okay, so we've just given our AI examples of what kind things could be and mean things. Again, we need to teach it first, so let's let it learn. Okay, close this so we can trace. Oh, that was quick. I like you is a kind thing. What an idiot is a mean thing. You have a great smile is a kind thing. So AI has learned now. So we write a post. I like your pretty smile is a kind thing. Great, we can send this. You have a terrible hair. Would be considered a mean thing, okay? And we can come up with all sorts of combinations. So from these words, I like your outfit, slime ball. Okay, so once we add the slime ball, the AI is not so certain. So liking outfit is being considered positive here, but the slime ball slightly pulls into the negative. Our AI has not been sufficiently trained. So we can come up with another scenario here. You have a clever smile. Okay, that's a kind thing. So you can see how we can train an AI to help us to identify whether something that we write is kind or not so kind. Okay. Good. We can also use AI for science. So this is a scenario where students conducted an experiment. It was specifically about the reaction rate of hydrogen peroxide and potassium sodium tartrate with the catalyst cobalt chloride. And students conducted the experiment 3 times, recorded their findings, the reaction time here over temperature. And you see the lower the temperature, the higher the reaction time is. The question now is, what is the best curve to fit over this data? And our AI can actually tell us. We can let it learn. And you see how the AI starts fitting a curve over our measurement points. Okay. We can now pull this over. And this will give us the curve, okay? And from there can we deduct what might be the best mathematical curve to apply this. But in the first step, the AI has done what we do usually quite naturally in our brains, is an approximation of these points and fitted a curve over that. Great, back to our presentation. There are some misconceptions about AI. Some people believe AI is always about robotics, as you've seen. That is not the case. In most cases, actually, AI is not connected to robots at all. But like any control and decision system, it can be. The second misconception is that AI only works with big data sets. As you have seen, AI also works with small data sets, less than 10 in some cases, as you've seen in our examples, and that is quite suitable for a school environment. However, if you've got access to larger data sets, that improves accuracy. Like in our anti-bullying scenario, the more examples we have, the more reliable the system will be. So how is AI different from conventional computing? In conventional computing, a programmer writes a computer program and that precisely instructs a computer what to do to solve a particular problem. AI is different. Here, the programmer writes a general purpose program, the AI, and that allows the computer to learn to solve a problem by itself. All the user does, feeds data into the AI. Or in other words, in conventional computing, we have many programs for many problems. In AI, we have one program for many problems. In conventional computing, we have lots of if, then, else statements to cover all possible cases, whereas in AI, we have lots of data examples instead. No if, then, else statements for the different cases. The different types of AI. At the moment, most of the AIs that we are dealing with are so-called narrow AIs. They're good for a single purpose. For example, playing chess, helping with anti-bullying, fitting a curve, and these kinds of things. General AI is what we haven't seen yet. Maybe one day we will. This AI would be able to think and act like a human. To this point, these AIs are still in the realm of science fiction, as are super AIs, which are super intelligences, superhuman AIs, which think much better in all ways than humans. Again, we haven't seen them yet. So for the purpose of AI in a school environment and even in industry these days, narrow AI is what we have. Part of AI are, and you've seen that already, artificial neural networks, ANNs, some of which they're also called deep learning because of the many layers that they can have. You've seen a 3-layer artificial neural network in the previous examples. These are inspired by the workings of the biological brain's neural networks. ANNs, artificial neural networks, are very good to learn to identify patterns by using a feedback loop to learn from mistakes and improve their results, just like the human brain. And this is a very nice link to biology that we can explore with our students, because we can use the AIs in order to help simulate and show to the students what might be happening in their brains when they learn, therefore giving the students better insights into their own learning process and learning strategies. So we're back to My Computer Brain. We're clicking on this robot here to the right, to a little AI system. Going to this picture with a brain. It's called How Do We Learn Best Part 1. Click on it. Okay, if you haven't logged in, now's a great time to do that with the teacher account that you have previously generated. Okay, so here we have a similar setup as our first example where we want to recognize the letters. Now, a typical scenario in the classroom is that we never have enough time to learn everything in one go, so we need to partition it. In this scenario, a bit artificial though, we're learning the letters A to E in one day and then F to J on the second day. So we start learning. We speed it up because you already know this. So you see how we're doing A to E. So our little artificial neural network is only learning the letters A to E now. And again, note the color changes here with the synapses. Okay, we're done. We've got A, yep, lowercase, uppercase. We've got A to E. It's all there. Our network has learned it. Very good. Now the students go home, teacher's happy, students are happy, they come back the next day, and the teacher says, today we are learning the next letters F to J. Great, F to J it is today. Okay, so students learning F to J only. You note how the colors are changing down here with these synapses, also slightly up here, but we're not concerned about that yet. F to J. So, F, G, H, I, J. Well done, students have learned the new letters. But when the teacher goes back and asks the student about the earlier letters, A to E, the students have forgotten. They no longer recognize these letters. And the reason for that is that these synapses, they're always active, they always learn. So by not doing any revision, this new knowledge has taken over and has severely pushed the old knowledge into the background. Sometimes we see ghosts of the knowledge, like here with the D in here, but the D is very faint, so students would be absolutely uncertain. They would rather consider this as a H. And this is, of course, not something that we want. So what can we do about it? Well, we click on the next button and go to the next experiment, which is part 2. Here we explore different learning strategies. So the first part of the experiment is the same thing. We learn just A to E. That's the same as in the previous scenario. No changes there. And I might just speed this up here. Right. Same as before, we have successfully learned A to E. Now, students go home. Again, the students are happy, the teacher's happy. They come back the next day and want to learn the letters F to J. But the teacher this time applies a different learning strategy. What the teacher does is that we revise the old content and then we do the new content twice. We revise the old content, the old knowledge, and then we do the new content twice. Let's look at that. We do it slowly first so you can follow. Okay, F to J. So we do F, watch the black box, H, I, J, and then we revise the old knowledge, which is still very much there, with the exception of the B, which students have partially forgotten, but that's okay. We bring it back. We do E, we do F, and you see the students have not yet learned the new letters. No? But just different learning strategy, old content, new, new, old, new, new. We speed it up again, see what happens. Okay, and observe the dial, how it's jumping back and forth. Okay, of course, having to revise the old content is to a certain extent stressful because it's much easier to forget rather than consciously remembering something we have done yesterday. So, our students are learning. Okay, but the learning is not yet firm enough. But you see the general trend, it's going up. We're now in orange, slight yellow territory already. Okay. Sometimes we get confused, then we step back. And this is when the dial goes back and forth quite violently. But we are slowly but steadily approaching the end point. This takes longer because we don't forget. Okay, we're there. So what have we done? We have an A and an A. We have got a B. B is not good. Students have forgotten the B, but here's the C. C is good, D is good, E is good, F is good, G, H, I, and J. Okay, so whereas in the previous scenario we have forgotten 50% of our knowledge, in this scenario we have retained 90% of the knowledge. There's still something wrong with the B, okay, but we can fix that later. So you see how we can use artificial intelligence in order to show to students that revision is important. And we can now show it. We not just have to argue about this, but we can show students, look, this is happening in your brains. Revision does the following. You retain knowledge, your synapses stay active, and the knowledge in the synapses is still there. It's a very useful tool to explain to students how different learning strategies work in their brains. So that was the link to human learning strategies in biology. So what makes artificial intelligence so unique? It is able to deal with what we call fuzzy data, data that deviates from the ideal case, and then still come up with sensible suggestions. In conventional programming, we would struggle to come up with all the possible combinations. As I showed earlier, in a 7x5 matrix, there are 2 to the power of 35, like over 34 billion possible combinations of black and white pixels, which means 34 billion different images. And as I showed you earlier, when I tried to go from the E to the F and back, the AI was able to cope with that quite well, although it had never seen those particular patterns. Okay, it looked at similarities. So what are the moral issues of artificial intelligence? Now, as we enter the era of self-driving cars, we should ask ourselves the question, what do we want those vehicles to do? Should it, for example, stop if it detects a pedestrian on the road with a 40% confidence? I'm 40% certain that's a pedestrian. Should I stop? What is the right threshold to decide whether the computer has recognized the pedestrian? 40%, 60%, 80%? Who picks these numbers? Because if the threshold is too low, the car might brake unnecessarily, interrupting traffic flow, causing collisions of the cars behind it. And as a consequence, people in those cars might get injured or killed. But if the threshold is too high, the car doesn't brake if it recognizes a pedestrian not sufficiently, and it could kill the pedestrian. We have a potential loss of life in both scenarios. Or would you accept your legal case to be ruled by an AI judge? Perhaps that's a good thing, because the AI would know the law very precisely, but it would not have any compassion. What if the AI reaches conclusions that go against our human ethics because it is more efficient? I mean, we are deploying self-driving cars because we want them to be more efficient than human drivers, not get tired, not get distracted. But what if they come to a conclusion which is so optimal, but it goes against our human ethics? Killing the grandmother versus the baby. Who decides what is better and what is right? Let's look at AI and the Australian curriculum, specifically digital technologies. So artificial intelligence is not mentioned explicitly in any of the content descriptors in the Australian curriculum digital technologies. However, it is a good application of computational thinking, abstraction and decomposition. It provides valid and interesting context and applications for curriculum skills and knowledge about data and algorithms. Remember, AI is a lot about data and data patterns. AI is also an industry-relevant area of computer science, and it's also an area that your students have already experience with, because most of your students would already have tried Siri or Alexa, which means you've got hooks into these topics and can explore with the students what might go on behind the scenes. It's also relevant to students in the context of video streaming like Netflix. It's rich in potential real-world applications for investigation, such as driverless cars or face recognition to unlock a phone. It is highly suited to a discussion of the ethical and social impacts of technology, because we are handing over decisions now to computers that make life and death decisions potentially, as in the case of self-driving cars. The topic itself is scalable for understanding concepts, and it can start easily with primary through to secondary students. Here are some of the connections to the Australian curriculum, and we have the key concepts of abstraction, digital systems, data representation, data collection, and data interpretation. You will find more about the key concepts at this link below. These are further key concepts: specification, algorithms, implementation, impact, and interactions. If you go to the link below at the Digital Technologies Hub, you find a mapping of AI against the relevant content descriptors in the Australian curriculum digital technologies. There are other links with other learning areas and the general capabilities. As I mentioned earlier, AI connects well with other subject areas, such as biologies. It allows students to reflect on their learning strategies to become more effective learners, and it provides a useful context to explore ethical understandings. Some resources. You've already seen the My Computer Brain resource, which was developed here in Australia and mapped against the Australian curriculum digital technologies with a large number of examples, such as anti-bullying, image recognition, face recognition, AI librarian, and so on and so forth. This AI is interesting because you can observe it as it learns. It is not a black box. There's an AI topics page on the Digital Technologies Hub, which is worth exploring. It also contains lesson plans for you. There are videos on the Digital Technologies Hub as well that concisely define AI and give examples of what it does. There are further lesson ideas on the Digital Technologies Hub, which have been developed, and there's a growing number of them coming, and webinars which describe artificial intelligence. Here is an example of an article on the Digital Technologies Hub from the Sydney Morning Herald, where AI is used to help issue flood warnings in India. And then there's a research report linked below at education.gov.au about artificial intelligence and the emergent technologies in school. Highly recommend this one. And then there are webinars on the Digital Technologies Hub, such as this one, which Martin Richards and myself did at the end of last year, where we unpacked artificial intelligence. In summary, AI is a very interesting technology which is about making computers smarter by allowing them to learn. Machine learning is the application of AI using big data and powerful computing. Some of the approaches in machine learning, artificial intelligence, are inspired by biology, as you've seen with the artificial neural networks. And finally, AI connects well with the Australian curriculum, and it can be an instrument to help reflect on human learning and to make your students more effective learners. Thank you very much.